So we'll start the recording. How are we generally feeling about assignment 1 though? 90% of you have already submitted, so I'm guessing pretty good. I don't think it's anything too complicated. Even if you're falling behind, you might have understood it. How many of you, just show of hands, have actually submitted already? Okay, so 90% of the class, yeah. That's a pretty good sign. Anybody who hasn't submitted, it's due at midnight tonight. If you need extensions for whatever reason, please send me an email and I'll get to it later as well. Okay? So we'll do one more quick recap in case you forgot. Are we all familiar with these? Does everybody remember these every time they open Blender? Does anybody open it and forget how to do any of this at this point still? I hope not, because we're 3 weeks in. But if you do, it's still here in the slides for you to look at and remember. I've also posted the slides in advance today, so you can download them right now and follow along and go through them. There's dedicated step-by-step slides as well where you can recreate examples and go through them on your own pace. Okay? G is to move, R is to rotate, S is to scale. This is the same in object and edit mode as you know. We can use Shift A to add a primitive. All of these hotkeys that I'm kind of going through here, I'm going to start taking out of the slide deck when I'm doing my examples. So when I say add primitive, at this point you should kind of just know that's going to be Shift A. Okay? We can use Tab to move into edit mode, and it's all the same there as well. So all the moving, rotating, and scaling, basically from here on out when we're looking at the slides, I'm not going to be including the orange hotkeys for those anymore. And that way hopefully you start to remember them and use them on your own. The other two we're missing are inset and extrude. So inset and extrude are going to be on I and E. We'll include these for a little bit longer, but you should have got a few chances to use them by now. Josiah, I believe, spent a lot of time using these with you as well on loop cutting when you were making these saws. How did that go with everybody? Good. Okay, awesome. I hope you'll continue to do the super hand-over-hand stuff with you so you can contribute to your weeklies and just kind of go bit by bit and sort of expand on those fundamentals. Continuing, we have vertex, face, and edge select modes. Also, you should be pretty familiar with these by now. You'll have to switch between them quite frequently using 1, 2, and 3 if you have a numpad, or the little buttons if you don't. And then we'll get into the new stuff. So everybody's familiar with all that stuff. I promise this is the last week. I'm going to run through it again. You've heard it 3 times from me now. That'll be the last time. So the first thing I want to introduce today is something that you're probably familiar with, something you've probably seen in your file, but aren't quite sure what it does maybe. So that's going to be the object origin. So when we're looking at our objects, we're seeing this little yellow dot. What does it actually do? So that little yellow dot, the origin, is where all of our math, modifiers, and actions are going to take place when it comes to our object. So I kind of talked about the mirror modifier. We'll talk about it a bit later, but modifiers like the mirror modifier will look for the origin point and use that when deciding where to mirror, where your line of symmetry is going to be drawn. If you're going to snap objects to one another, then you need to know where the origin point is because the origin is what it's going to use to snap from one object to another. Right? So a big skill that we need to learn is how to manipulate this origin, how to move it around for different types of modeling. Okay? When we move our object in object mode, you'll see that the origin is going with it. So that little yellow dot is staying relative to the mesh itself. So in this case with this cube, it's staying right in the center of the cube. Okay, so when we're moving objects in object mode, the origin does not move. However, in edit mode, when I move this cube around, you'll see that my origin is staying right in the center. So in edit mode, the origin does not move relative to the mesh. The mesh is moving on its own and the origin stays put. Okay. What are some reasons for this? Well, if we use that other example of where this mirrors, so imagine that where this origin point is, we have this big line of symmetry. We want our mesh to mirror to the other side of that line of symmetry. And if I move it in object mode like this, it's going to stick with the object instead of allowing us to have a duplicate of it on the other side. Okay. So if your object is moving around and the origin is not in the spot it's supposed to be, you've probably changed it in edit mode. But now we have to move it somewhere that's appropriate. So I've got a quick example here about moving the origin. when we export these, typically we also want to export our meshes the way that they're going to appear in game. So in this case, I've used a light post. Real quick, I'm sure you can all answer me on this one. Where should the origin go on this object? If I was going to put this into a game engine, where should I probably want 0 to be? Yep.
I'd probably say around the middle of the bottom of the light post.
Middle of the bottom. Can you explain a little bit why?
Because when you put it into like the game world, you want to have it be like perfectly on the floor. So you want to put like the origin point on the floor, and I feel like that'd be a lot easier than just like dragging it out and trying to eyeball it.
Yep. That's exactly right. So a lot of these game engines even have additional features that let you ground out an object just by hitting a key, and it's going to use that origin point. So if that origin isn't somewhere that's the ground, in this case for a light post, it's going to be a hassle for you to drag and drop this into your engine. You're going to have to adjust it on the z-axis until it kind of looks like it lines up with the ground, and then you're probably off by a bit. Maybe you're not using snapping, right? As opposed to just dragging and dropping. Right? So every object's origin, we're going to think about where it should go relative to our game world. You have to think in advance a little bit here. We're thinking about where this is going to end up in game more so than where it is right now. How do we actually move this origin to the bottom? Well, that's a good question. We can use selecting and object editing to move our origin around. So earlier when I showed this example, the way the origin moves with the object in object mode, it's because the origin is part of the object, not the mesh. Right? So this is an object function that we're going to use here. If we select the bottom of a light post like this one, right, this ring, we can move what's called the 3D cursor. Does everybody know what the 3D cursor is? Yep.
It's that like weird like circle thing that always appears at 0, 0, 0 when you first open a project.
It is. The 3D cursor is what we use to spawn new objects in. That's where they spawn. And it's also something that we can use to move the origin point around. So if I open up a Blender file here, and I hit Shift, and then right click, you can see that little life ring looking thing is moving around. So that's my 3D cursor. So wherever we click in 3D space, this will kind of attach itself to a surface and go there. So if I wanted to add a box, for example, another cube somewhere around here, I could Shift, right click, and then Shift A to add a new cube. If I wanted to add one over here, same thing. But something else we can do with the 3D cursor is move the object, or the origin of an object. So if I select the bottom ring here, we can use Shift S. So that's the new tool for this, Shift S. We're going to be using quite a bit. Shift S does a bunch of things, but what we're going to use it for right now is moving the 3D cursor. So again, there'll be, in like a couple minutes, a chance for you to go over this yourself with an example. But if we just look up here, you can see we've got object options like cursor to world origin, cursor to selective, cursor to active, selection to grid, selection to cursor. But the main two I want you to focus on right now are cursor to selected, and at the top, selection to cursor. Those will let you move your 3D cursor to certain places or move existing objects to where your 3D cursor is. So if I go back to this example here, if I want this square, now it's over there, but I want to attach it somewhere over here, I can click my 3D cursor, hit Shift S, and use selection to cursor, right? And based on wherever this origin point is, it's going to move my object to my cursor. So another use of that, if my object is off in space like this, and I want my object to go back to the world center, right? Maybe I want my object to go back to 0, 0, 0. I can use Shift S, and down here we have cursor to world origin, which is going to put my 3D cursor right back at the beginning. I can select my object, Shift S, and selection to cursor, and I'm going to move that back to the world center. So that way if something you've modeled is accidentally off to the side, you can put it back in the center. right? So hold Shift and S, and then you can flick your mouse downwards. That's the easiest way to do it, right? Instant. Okay. After we've moved our 3D cursor, so if this was our lamp post, for example, we can go ahead and go to face mode and select our bottom face where this would sit. Shift S, move our cursor to the bottom. I can tab back into object mode now, and from the top go Object, Set Origin. You see I have a bunch of options. I can move the origin to the geometry, I can move the geometry to the origin, or in this case, set origin to 3D cursor. So now it's going to move my 3D cursor to the bottom. Or my origin, sorry, to where my 3D cursor is at the bottom, right? So now if this was something like a house or other kind of prop, I know that the bottom is where the origin is. And when I move the object back to world center, it will sit flush on the ground if I was to bring this into an engine, okay? The other option is you can use Shift plus C, and that will just instantly reset your cursor and your viewport. So if you've somehow gotten completely lost, you don't know where you are, your cursor's all over the place, if you hit Shift C, it will reset everything, and you'll be right back to the default view. Okay, so I just showed these, but Shift S plus mouse up, you can read through the slides here. And at the end, you'll have an object properly lined up with the world around it. So instead of moving on too quick, I want to give you a chance to attempt this with a few different objects. Think about where the origin might want to go. So this is the part, if you have the slides downloaded, there's 3 slides basically in a row, just going step by step with all the different things we need to do. I'll do it with you here as well, but if you have the slides, you can go at your own pace, whether that be faster or slower. So the first thing that we're going to do is add a new object using Shift A. So I'm going to go ahead and hop into Blender here. We'll pretend I didn't do this one already. And I'll turn on my hotkeys. So from here I can add a new object. We'll add a cube. Okay. Then I can tab into edit mode. So hit tab. I know I'm in edit mode because up here in the top left it says I'm in edit mode. I'm going to switch to face select mode for this, because when I use Shift S to move my cursor to selected, it's going to go in the middle of my selection. So if I was to select something like these two and I use Shift S, you'll see it's kind of averaging out between the two middles of these faces. Okay? So if I select the bottom face, it's going to put it right smack dab in the middle of the bottom face. So Shift S, right? You can either hit the number 2, you can Shift S and hold and then snap your mouse downwards and it will do it when you let go, or you can hit Shift S, take your hand off, and then click cursor to selected. All of these will get your cursor to the bottom, right? Okay. So that's those 3 steps there. Because the origin is an object mode thing, we can't move the origin while we're in edit mode. We have to switch back to object mode before we can actually move the origin to where our cursor is. Right? So right now you see we don't actually have the object option up here at all until I switch back to object mode using tab. So now I can go object, set origin, okay, and origin to 3D cursor. Right, which puts it here at the bottom. Okay. Shift S again, cursor to world origin. Shift S again, selection to cursor. This is going to be really useful for all kinds of things. For example, if I was to make a plane and I wanted this to be tileable, right? In Engine, we want our objects to tile off the corners, not off the middle. It's a lot easier for the engine to work with when we're using the corners. So in this case, we do the same thing. I'm going to hit tab. I'm going to click one of the corners that I want my object to rotate around or scale around or move around. Shift S, cursor to selected. So it doesn't have to be a face. It can be a vertice or edge or anything like that. So cursor to selected. it's going to move it to the vertice I picked. And then we're going to do the exact same thing. Tab back into object mode, set our origin to the 3D cursor, Shift S to move to world origin, Shift S again to move our selection to our cursor. Okay? And from here, I could build up a plethora of modular pieces. So if I rotated this one, okay, Shift S, move it down, switch to object mode. It's the exact same steps. I'm going fast now, but it's the exact same thing. Move the cursor, move it back. Right now, I've got a wall piece for my modular kit. Okay. Now, are all props going to have their origin at the bottom? No. Not all props can have their origin at the bottom. For example, let's say I'm building something that I want the character to hold in hand. I typically am going to want the origin to be in the middle of the object so that it's easier to snap it into the player's hand when animating or doing other things like that, right? Any objects that are floating should probably have their origin sitting somewhere in the middle unless they're part of some larger grid system, right? But typically, you will get pretty quick at this where you're just quickly going to select the bottom, moving your origin, and then snapping everything back to get started. Okay. Is everybody pretty familiar with that? Okay, we're going to be using that a lot more later when we start to get into using modifiers like the mirror modifier, because for that, it's quite essential. You'll see now from my origin, though, if I rotate, right, I'm rotating around that origin point. So if I rotate my cube now, it's not rotating in space, it's rotating around that origin. Same thing with scaling. When I scale, I'm going to scale around that origin point, right? So this also just saves time. Let's say I'm in a game engine and I want this house to be bigger than what I modeled it as, just by a little bit. Instead of scaling it up like it normally would, right? Pretend the ground is here. Here's the ground. If I line this up perfectly in engine with the origin in the middle, if I then make my house slightly bigger, it's going to start crashing through the ground, and I'm going to have to move it up. Or if I make it smaller, I'm going to have to move it down. Smaller again, I'm going to have to move it down. Or bigger, I'm going to have to move it up. If the origin is at the bottom, it will stay on the ground as I scale it up and down. Okay, so it's all just about long-term planning and making your life easier when we're working with the actual game objects. Okay. After snapping, the next tool we're going to learn about today is building faces. So this is another core component of 3D modeling. There's a couple new tools that go with it. Anyone familiar with what a face is, right? I assume you are all familiar with what a face is, right? A face is just 4 vertices connected by edges and a triangle drawn on each side in between. Okay, that's all it is. It can have more than 4 vertices, it can have less than 4 vertices, but generally speaking, it's just a series of vertices all connected by a plane. Okay. And something that comes up often when we're modeling is actually building faces. So I'm not sure, maybe you've come across this, maybe you haven't, but there are often times where we've got some kind of structure and we're missing, I don't know, a face here, let's say, to block that wall off, and a face on the top to block that wall off. And you're not sure exactly how to go about replacing those faces that you lost. Okay. The hotkey for this one is first you're going to shift click all of the vertices that you want to turn into a face. And the hotkey for actually creating a new face is F. So once we've selected 4 or potentially more or 3 vertices that we want to turn into a face, we can hit F and it will draw the new triangles in between. Okay, so in this case, in this example, in this GIF, it's just closing the box that was missing 2 faces, right? And you might think this isn't something that comes up all the time, but if I was to quickly just create a area like this, and I don't want this section here, right? Now I've got these empty bits that I need to replace, okay? And again with this, don't follow along with this, this is just example, okay? So now that I have these empty bits, I do need to go in, select my different vertices, hit F, select these 4 vertices, and hit F again. Okay, and now I've got my little cutout that I was trying to build. So we can select, yep, Jason.
The
Does F2 allow you to fill those faster further?
Yes, I'm going to ignore it with it being an add-on and some people having trouble installing it, but you can theoretically just select these two and F2 it.
And it follows your mouse?
Yes. But yeah, that is an add-on or an extension. You can get it from the extension window, or you can just select the different bits yourself. Okay. So we can select any number of faces, or sorry, any number of vertices to make face except for one. So we can select 2. What do we think we get if we connect 2 vertices with F? How come we make a face? Yeah?
We get an edge.
We get an edge, right? So when we connect just 2 vertices, we're getting an edge, not an entire face. But sometimes you want to fill a gap that's not any particular number of vertices. It's not 4, it's not 6, maybe it's something like this, where in this case it's 6. It's more than 4, right? So when we're trying to build up with quads, when we make a new face here, we've got 6 sides. So this is called an n-gon. So an n-gon is any face with more than 4 sides. And n-gons are typically very bad for a variety of reasons. So I'll demonstrate one reason here quick, and then we'll talk about how we can fix them. So if I duplicate that sort of shape I just had there, so we go 6 sides. I guess that's kind of it, right? So I've got all of these nice quads, quad, 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 and then on the top we've got this n-gon. The reason n-gons are bad is because, as you can see, I'm moving these 2 vertices up and down. You'll see the face over here, the lighting is changing because the angle of the plane is changing. But on the top, the lighting is not changing. It's because it's being rendered in a really, really finicky way. It's actually what's known as non-planar. And what happens with non-planar faces is they can be interpreted in a number of different ways, right? So the engine, the render engine, is trying to interpret this face the best it can, but there's only so many ways that it can actually be rendered properly. So you'll see if I go in, right, we can shift-click different vertices and hit J to correct these n-gons, okay? But there's a little caveat, J can only be used on faces that already exist. So if I try to hit J over 2 just like random floating edges, I'm gonna get this error, cannot connect vertices, right? If you have 2 floating vertices like this, that's when you're gonna use F to create a new edge. So shift click plus J. So this is gonna cut, yep.
This is just kind of unrelated. I learned a lot of this online by by trying to figure out how to make my V2 model.
Yeah.
And it's nice to know more of this in detail, and it's like, oh, that's why that happened. That's why it was like that.
Yeah, I'm hoping you'll have a bit more of an understanding of all of these different things happening as we kind of go through it and do the example. I can definitely give a lot of information on the rendering side of things, since that's mostly what I focus on. So if we look at this, right, and we say, okay, I want to make this one a quad here, and this one a quad here, so I can hit J, and you'll see the lighting changes. Now I've got one face that's pointing the other way and one face that's pointing this way, okay? But because it's non-planar, if I get rid of that edge again, if I connect these 2 vertices instead, I've got an entirely different shape, right? It's hard to wrap your head around because it's non-planar. It's essentially trying to exist in 4D, and we can't really do that. Right, so if I connect these 2 edges, I get a totally different shape. If I connect these 2 edges and these 2 edges, maybe I'll get a completely different shape.
If you hit
right?
F after selecting those 2, does it do the same thing?
If you hit F after selecting 2, you create what's called a fake face. So if I hit F, nothing's actually happening. You'll see it's drawing that edge, but it's not connected to this face at all. So if I delete the face, those edges are still there. Right, so I can delete the edge, and now it's gone, and everything's proper.
So is it like creating a new edge rather than joining 2 vertices?
Yes, yeah, that's the big difference between J and F. So whenever you're already dealing with an existing face, so you can see when I move this face, this vertice here and this vertice here are both moving. Okay, that means they're both connected to this face. So I know if I can use J to connect them, right? If I was to disconnect one of these, for example, so I'll just come in here, disconnect. So now when I move this, you can see that that edge is not moving. If I try to connect these with J, you'll see it gives me an error. Nothing happens. Or it connects it the other way, because it's going all the way around here now. Okay. Yes?
Is there any reason to intentionally create non-planar faces?
No. We use n-gons here and there in game modeling, but that's something we'll talk about a bit later, when and where you can use those.
I was just curious because I'm
Yeah.
like wondering like why do they have the feature in Blender if it's not entirely supposed to use it?
Yeah, that's a good question. Generally, it's because n-gons are a lot easier to work with in certain situations, like this one here where we have these 6 sides, much easier to work with than doing something like this, for example, right? If I want to make changes to this now, I've got a lot more edges that I'm working with.
Yeah, I'm always more asking specifically about the non-planar faces.
Non-planar, oh, okay, gotcha, yeah. So non-planar faces will not actually exist once we get to render time. It's not possible because every time a game engine is interpreting a model, it's going to interpret it as triangles. And if you imagine a triangle in 3D space, no matter which way you move those vertices, it's impossible for it to go out of plane. It's only with quads and further that you can be non-planar.
I see. So is there a way to highlight those faces like the inverse normals that we showed earlier, like just in case we mess up and make it by accident?
There is. So if you actually just hit the space bar, it brings up the search menu. And you can select, not non-planar. You can type in select faces by sides. And so when I hit this, it'll pop up a little option. By default, it's set to 4. So we can go in and hit greater than 4. And it'll select just these. So if I'm working on a mesh and need to debug it, I can go ahead and type in select faces by sides, find where my n-gons are, and then go in and fix them need be, right? You can still have non-planar quads. It is possible. It just happens way less frequently. So if I move this like this is technically a non-planar quad. You can see the lighting will change depending on which way I do it. There's no way to detect those using an automatic select with Blender. You kind of just have to keep an eye out for them. So what I'd recommend you guys do now, whoop, I hit end. That's not the right key. So what I'd recommend you do now is I'm going to have you make a new object. We'll go through it. We're going to set the vertices to 8. I remember earlier I said computers really like working with those numbers, 2, 4, 8, 16, 32, 64. We as humans also really like working with those numbers because when we're trying to quad everything out, numbers like 2, 4, and 8 are much easier to turn into quads. If I take this circle and use like, let's say 7, trying to find a way to quad everything out here is basically impossible, right? This one has 4, but now this one has 1, 2, 3, 4, 5, right? So try to stick to those even numbers. So in this case, 8 is just easy. That's what I recommend you start with. So we're going to make a new circle. So Shift A, and we'll find circle. Okay. In the bottom left, we can find the vertices tab and change it to 8. Just punch that in. And by default, our circle is not going to come with a fill. So what we're going to do is go into edit mode here. So I'm going to hit tab to go into edit mode. I'm going to select all of my faces, or all my vertices, sorry, and hit F. Okay. Right, so that's in the slides as well. And then we can shift click 2 vertices to connect. So in this case, I'll just pick the top and bottom one. And because this is one whole face that's all connected, I can just use J. So I'm going to go ahead and hit J. Okay. So now I've got 1, 2, 3, 4, 5 on this side, and 1, 2, 3, 4, 5 on this side. We're going to add one more edge to turn both of these into 4. So I'm going to go left and right now. Same thing, we know that these are all connected. Left, right, J. Okay. And now I've got 1, 2, 3, 4 quads. Does that make sense to everybody?
I got lost like near the beginning.
lost like near the beginning, I'd recommend you hop back into the slides and see if you can follow through this little example bit. But I'll answer your question too.
That was my question though.
The
Lentils still confusing.
It is confusing. It's going to take a while to get used to. But yeah, I'd recommend following just these 3 slides here a little bit. And it should help you understand what's going on.
I just feel like when I put a circle, it just goes down. It doesn't tell me how many vertices it wants.
When you make a new, it's in the corner there. So when you make a circle in the,
Oh.
yep, Jason?
If you're okay with the, so if you want the face to be perfectly flat, is it fine to have an end gun?
That's definitely more of an advanced topic, but technically, yes. In a lot of cases, you can have n-gons on flat surfaces. When we optimize our models for video games, usually we do leave the n-gons on those flat faces, or what we end up doing is just triangulating them like this to sort of reduce the number of triangles that we use. I'm not going to get into that too much now. I'd prefer if you guys modeled as cleanly as possible for just while we're getting started. Eventually, we'll learn about things like subdivision surface modifiers, and those, even on flat surfaces, don't work.
So if we had like a 5-point face that is like missing and we just want to build it and have it be completely flat, it's totally fine to have it be an end gun.
Yep, I'd recommend triangulating it at that point. So if we have a flat point face, for example, you just ended up with one somehow. Something like this. Obviously, it's impossible. You could add an extra edge, right? And now these are both quads. Or you could just make one of them a triangle like this, and that's generally okay too on flat surfaces. Okay. As long as the shading is okay. So you'll notice obvious shading errors if they come up when you're adding these n-gons, and those you'll have to fix, but generally it's okay. Does everybody kind of understand the using F and J to build new faces? Okay, cool. We'll go over one more quick example, but if I'm extruding a back side of something, oops. So sometimes a situation might come up where you have something like this, right? And I want to build this bottom part out to have new faces to match. Okay. We have to create the new geometry ahead using extrudes to build those new faces. So if I use extrude and then Y, we can build out this extra edge. And now I can select my 4 vertices and make a face. Same thing here. We'll extrude this out on the Y-axis. And now we'll make a new face. Okay. But there's one issue. These aren't perfectly lined up, which is probably what you want. So what do? We're going to get into snapping. So snapping is something I kind of briefed over last week but didn't really explain. This week we're going to go through actually explaining it, the use cases, how you can use it. I am not sponsored by Rice Krispies. At the top of the screen, you'll see this little icon. It is a magnet. Okay, there are 2 ways to turn the magnet on. I didn't leave the hotkey in here because it's not super prevalent. But the hotkey is Shift and Tab. So you see when I hit Shift Tab, this little magnet is going to turn blue. So when it's blue, it's turned on. And beside the little magnet, we have a panel. Okay? And in that panel, we have a bunch of options, but the 2 I want you to get familiar with right now are going to be Snap Base and Snap Target. So Snap Base, we have 4 options here: closest, center, median, and active. And Snap Base is talking about what we're going to use to snap. So not where we're snapping to, right? This is what we're going to use to snap. So if we have an edge like this one here, there's 3 different examples. Median is going to snap using the median of your selection, whatever that may be. So in this example case, we've got one edge. The median of that edge is going to be its center, of course. Right? And in all these examples, see this little white circle? So in all of these examples, we're hovering our mouse over that corner where the white circle is. Okay? And these are the different results. So with the median, we're taking the middle of that edge and we're snapping that to the white circle. Okay. Using active. Sometimes you might notice when you're working that one of your vertices that you have selected, or one of your edges or one of your faces, is a different color than all the rest. So if I use this example right here, even though I have everything selected, one of these vertices is white when the rest are orange. If I go into edge mode, same thing. One of these edges is white when the rest are yellow. And face mode, same thing. One of these edges is white, or one of these faces, sorry, is white when the rest are yellow. That white selection is what's called your active selection. So if you ever see active in any of the different modes or anything like that, it's referring to this white part of your selection. So we can see in our example that the selected vertex is the same in all of them. It's this little one right there, the one that's white. If we use the active selection, it's going to snap our current vertex, so the white one, to that yellow circle, or that white circle. Okay. In object mode, instead of using the selected vertex, right, because you don't have any vertex selected in object mode, it's going to use the origin. So again, another big reason to want to move this origin around is we can use it for snapping, right? So that's all written there. And then closest is something that you'll also be using. Closest is going to just calculate the distance between each vertex on the object you're snapping to and each part on the object that you're snapping, and just mash them together as closely as possible. So in this case, that edge, it's grabbing this corner vertex that happens to just be the closest to the white circle, and it's moving our entire selection there. Okay. You'll notice I left center out. Center, we don't really need to use it ever. Just worry about specifically active and closest are the ones that we're going to be using the most. Even median, there's a time and place, but it's not super frequent. Next is the snap target. So that's how we're going to snap. This is where we're going to snap. If we use increment, it's just like any game engine. It's going to snap in some kind of increment using the world grid. So the world grid by default, if you open Blender, is actually a series of 1 meter squares. So if we look at our default cube here, each one of these is 1 meter. 1 meter, 1 meter. Sorry, so we know that the default cube is 2 meters by 2 meters. Okay? If we use increment snapping, we're going to snap along whatever visible grid we have. So if I zoom way out like this, you'll see we get these big snaps on the big visible grid. But if I zoom in, you'll see we get these much smaller snaps on the now smaller visible grid, right? And you can extend this even further, right? So now we're in like absolutely minuscule levels of snapping, right? So increment is pretty useful for doing big, quick changes. Okay? And it works in every direction. Yep.
You know how you showed us how to like move stuff with world origin? If you can do it in this instance, what's the point of like doing all the steps to like move it to a certain place? Or is it just for like really random things if you want it between like 2 points?
You can use it, you can move it just about anywhere, but like the example I gave earlier was if I move the origin to the bottom here, when I export this to a game engine, it's going to stay on the ground, right? When I import it. When I scale it, it's going to stay on the ground, right? All of these different things. Also, different modifiers may use it differently when we're working later. If I was to mirror, for example, it's going to mirror wherever that origin is. So sometimes maybe I want that origin to be in a different place just to mirror a specific part, and then I'll move it back somewhere else. We'll talk about the mirror later, though. Okay. The second option is grid. This one's a little bit funky. It's going to snap directly to the world grid. So if you have, let's say, a cube here, and I'm not going to use any snapping, and I've just kind of moved it like this, you can see right now it's not lined up with any grid. But we know that these grids are real world measurements. So if we want this to be 2 meters, I can use this snap to grid, right? If I use increment, it's relative. So if I move it, it's never going to line up with the grid again because it's already off the grid with increment. If I use grid and I hit GY, you'll see it's snapping to whatever grid point my cursor is touching. So now I can move it down here to 2 meters, right? So 1 meter away. Okay. And now we know that it's perfectly lined up with the grid. The next one is technically 3, but that's vertex, face, and edge. And they do exactly as you would expect them to. If I was to create another object here and move it somewhere else, if we use vertex mode, my selection using the origin is going to snap to the vertex that I hover. So if I hover over this one, it's going to go there. Right? So snap to active, this one, that one, this one, right? It's going to go to whichever one I'm hovering that's a vertex. If I change it to edge, it's going to do the exact same thing, but it's going to go along the entire edge. Okay? If I want it edge center, right? It's the same thing. It's going to snap to the center of the edge instead of along the entire thing. And face, finally, same thing. It's going to snap to whichever face, right? Vertex is the one you'll probably be using the most. Okay. So why do we actually want to use this snapping? Well, there's a few different reasons, but the obvious ones are we can use snapping and axis locking to even out different things. So in that case from earlier that I made, where I just deleted these faces, right? Maybe we extruded this one out a little while ago. I can extrude this edge out and make a new face, right? Just like we explored earlier. But now it's not in line. But using snapping, we can move this vertex to be in line with all the rest of ours. So I can use G and Y, and maybe I can use the grid snapping in this case to just snap this to the same level. So boom, there it is. Instead of the grid snapping, I can use vertex snapping, let's say. I'm going to hit G and Y again to lock it to the Y axis. And this time we'll snap to this vertex, right? And that's going to also achieve the result of a perfectly flat edge. Okay? So now we're all even. Another example is maybe you're creating something in different pieces, and you want the different pieces to snap together. So an obvious example is something like this, where maybe it's a piece of a mech, and you want it to snap to another piece of said mech, or a doorway, or something along those lines. So if I move this cube up, I'm doing the exact same thing we learned in the slides. Shift down, tab to object mode, move the origin, snap it. And if I create another one of those quick example pieces, right? This time we'll use closest, and maybe we can snap it to this corner or that corner, right? So if it's something like an angle brace for the corner, we can snap it into place. Okay, super simply. Now it's there. Okay. Everybody good so far on snapping? It comes up a lot, so you are going to have to get familiar with it. So what I want to try for this example is less slide focused, less reading. I've actually provided a snapping example. It's just 3 quick little quiz style examples that you can go through and look at yourself. You can use the slides and just sort of explore what we talked about here. So I'll download it myself. It should be open on Canvas now. As long as you're using Blender 4.0 or later, it should be compatible. So it's just here, snapping examples.blend. If we feel like this is a good way to structure things, then going forward, I'll continue to make example files like this that you can solve on your own. The answers are also in the file, so you can figure out what you were supposed to do. All right, so this is not the weekly. This is just examples for example's sake, to hopefully get you understanding the snapping bits a little bit better. So I'll give you like 5 minutes to sort of go through that, and then I'll do it also live after, and then we'll look at the examples or the answers. If you're skipping ahead and you don't want to wait for me, the answers are in their own folder. So it's a folder in the listing up here. If you click it, it'll just open up. Oh. Wrong version of Blender. Okay, there it is. So I got rid of all the windows you don't need. Even there's no like viewport. This is everything you should need. Is just the viewport. Snapping examples. There's just 3 quick examples, right? So the first one is you're trying to take this face and snap it to this edge here on this plane. The next one is trying to make all of these pillars the same height using snapping. And then the last one is making these blocks specifically 2 meters apart. Okay, so 3 quick examples, but once you're done all of them, you should have a pretty good idea of how to snap different things together. So I'll give you like 5 minutes now to run through that. Sound good? Perfect. Oh, sorry, one last thing. If you want to look at the answers, what you'll have to do is drag out a new window. So I'll bring my cursor up to the top right of the window, drag out a new window, and change this to the property editor. I hid all that stuff because it's not super necessary. Okay, and then the answers are just in their own file. All right. Starting with the first example. So what I wanted you guys to do was snap this face here to this edge. And there are a million different ways you could do it. I purposely made sure not to line it up with the grid. So if you zoom in close enough, you'll see it's not actually lined up with the grid at all. To try and force you to actually hop into edit mode here. So we're going to use tab to go into edit mode. Turn my screencast on. Tab to go into edit mode. I'm going to select the face. And for my snapping options, right, you see if we use increment, it's not actually perfectly going to line up. If we really, really get down here, it's not perfectly lined up the way we think because I made sure it wasn't lined up on the grid. So what we have to use here is some form of geometry snapping. In this case, I can just use active and vertex, hit G to move it, Y to lock it on an axis. And if I snap to either of these vertex, it'll snap to this face. So boom, I know these are perfectly lined up. Okay. For the next example, making these pillars the same height, same sort of thing. I'm going to select a face. I'm going to use, in our case, angle snapping again, or we can use the grid. Either one works. So I'll move it to here on the grid. We'll move this one to the same height on the grid, and we'll use GZ again to move this one to the same height on the grid. Okay. So once these are all on the same grid level, we know they're even. We can further confirm it just by going into vertex mode and snapping everything. And now we know we're good. Okay. And the last example was to make these blocks 2 meters apart. So this block is sitting right on the x-axis, which means we need this block to be 2 meters away. This is another one of those ones where you can use the grid. You can see if we use the grid, it's going to snap directly. Each one of these boxes, if you remember, is 1 meter. So if I go here, that's 1 meter. If I go here, right, I've got 2 meters.
They have dragged the other one to the x-axis and then dragged it.
Either way works, as long as they're 2 meters apart. So if I open this up here, you can see the answer key as well. It's just the same thing, basically, or what your target was when you're working on it. Jason?
Could you show when median would be used?
When median would be used.
Because I was toggling between the two, and it seems to be a lot mistake.
Between active and median?
Yeah.
So if I wanted to snap to this vertex here with this vertex, let's say, if I use median, and let me switch back. Right, so vertex mode, I'm snapping to a vertex. If I use median, it's snapping the middle of this face to that edge. But I want them to be touching this vertex to this vertex. So if I switch to active, it's still going to move all these other bits.
I just snapped it to the same
Right.
part of the grid.
but it's going to go this vertex to this vertex, and everything else is just getting dragged along for the ride. Okay. Whereas with median, it's snapping to the middle, which is not what we want. So generally speaking, active is what you're going to use the most. Because if I snap like this with the vertex, I can snap the vertex. But if I wanted to snap the middle like I was before, I could just use face instead, which is a lot easier to switch to, and I don't have to switch modes, and I can continue working with the vertices a lot faster this way. So generally speaking, active is the way to go. And as I said earlier, if you use active, you're eliminating all chance of randomness, right? In this case, if I use closest, like it's probably going to be pretty spot on because it's a very simple mesh, but there's no guarantee it picks that this and this are the closest. It might do some weirdness, and then I end up with something a little bit weird. So if I just use active, I get the same result, but I've got a better understanding of snapping now, and I can guarantee exactly what I'm snapping where. So those are the key differences, really. Okay. So is everybody good with this? Everybody good with the example and went through the 3 problem quote unquotes there pretty simply? Anybody struggle or need a little bit more explanation with any of it? Pretty good. Is this a good format? Should I make more of these and give them to you?
Yes.
Yes. Okay. I will create more of these as we go week to week with more detailed examples as we go through, and that should help your understanding. You can always re-download this and start over if you get too confused. Okay. Let's carry on. So this is the last topic I want to introduce today. Then we'll get into the usual live example. I think I'm going to model a drill today. Not really sure. We'll see. Modifiers. So all the work that we've been doing up until this point is called destructive modeling. So destructive modeling is anything where the only way we can make changes is by manually getting rid of it or using the undo button. That's a lot. And if we know anything about the undo button, it's that it never goes far back enough. It's always just short. What we have instead is modifiers. These are what we call non-destructive modeling. So modifiers, they don't get affected by the undo stack. It doesn't work the same. They're procedurally being done to your mesh all the time. They're live. So in this case, I just have a bevel on here, but it could be any sort. There's a whole bunch. We're just going to talk about mirror today because that's the main one. But in this bevel example, we see we have an amount for the bevel. Don't worry about this too much because we're not going to use the bevels for anything, but I just want to use bevel as an easy way to showcase the liveness of things. Just open things up real quick here. If I bevel this normally, right? So again, don't worry about following along here. I know you're not familiar with bevel. It's just for case in point. If I bevel this normally like this, and I now want to undo this bevel, let's say I don't have any undo steps, I need to click all of these, dissolve them, find this edge, turn my snapping on, vertex active, snap this in place, then get rid of that. I've now gotten rid of my bevel. That took a long time. And this is just a cube, right? Imagine all kinds of organic forms connecting. If what we do instead is add a bevel modifier, right, this is now non-destructive. So I can always come back, and you see amount here, I can always come back and change how much it's beveling. It's procedural. As I add more, right, it's going to adapt. So now instead of needing to create a new bevel where I add more geometry upwards, right, I can just get rid of that edge and it's adapting, right? Extrude from here, it's adapting. It's going to add these corners, right? So again, don't worry about the bevel modifier specifically. We'll learn more about it later. Yep.
Are you able, like what you did before when you had like it just like this, are you able to do like the bevel modifier, or do you just need to cover?
You can use modifier. That's a little bit more complicated because you have to get into using like weights and stuff. I can set this to weight, and then I can set specifically this edge, for example. Set this to 1, set this to 1. And now you can see it only affects that edge. But generally speaking, it's less useful in situations like that. But anyway, right, so this is very modular, very flowy. I don't need to go back and hand delete this bevel. I can just get rid of the modifier and boom, it's gone, right? So very useful in a lot of situations, okay? Non-destructive modeling, super, super good. The one I want to talk to you about today, though, the only one we're really going to focus on for now, you can explore the rest of the modifier stack on your own if you really want to. And I might explore one more when I do the live example stuff, but for now I just want you to get used to the mirror modifier. So what the mirror modifier does is pretty simple. It works the same way as a real mirror, where you look and you see yourself in the reflection. Except instead of an actual mirror, we have a line of symmetry. I have full confidence in saying you've all passed grade 3, so you should all know what a line of symmetry is. Who can tell me? How many lines of symmetry there are here? This is a bad example, actually. Hold on, I should pick something else. Otherwise, we're going to be here all day. All right, who can tell me how many lines of symmetry this one has? Yep. One. Straight down the middle. Right? Okay. Why do we need to know this? Well, put it plain and simply, what's actually happening here when we're talking about 3D games and everything like that, we're working, in this case, in 2 dimensions. We have our x and we have our y. Our line of symmetry, when we're graphing this mathematically, is occurring at some point in space, some x value, right? And then the y value doesn't matter. Okay? In math, it's quite easy. We just add a constant to this, and we can move this line of symmetry back and forth. In 3D modeling, it's also quite easy, because to move this around, what we're going to use is our origin point. So earlier I talked about the origin point. When we're using the mirror modifier, imagine the origin point is where your line of symmetry is. Okay? Unlike this example, we can mirror in 3 different ways instead of just 2. We have the x, the y, and the z axis. In this quick example, you can see I've got my origin point here, disconnected from the mesh, and so I end up with 1 cube on one side. That's real. All right, so this cube is real geometry that I can edit, and 1 cube that's quote-unquote fake. I cannot edit that cube. It only exists as a reflection of this geometry. Okay, but there is a slight problem or something that happens with the mirror modifier, and that's if we move across our line of symmetry here, we're going to start crashing into ourselves. So our line of symmetry is basically that y-axis, because that's where our origin is. It's going to start crashing our geometry together with our fake geometry. I don't think it takes a rocket scientist to tell that when you have the same geometry on top of each other, you get bad results. Okay? There's something that we can turn on to mitigate this, and that's called clipping. So when we're clipping, what's actually going to happen is the mesh is going to crash into itself, but it will stop and join together. So it's a little option here. I've circled it. When you enable clipping, now instead of crashing together, they're going to meet at that symmetry line and merge together. This still does create some issues though. When we merge together like that, anybody want to take a guess what's happening to this face? Yep.
It's going to go in.
Yeah, the face is going to go in. When it merges, it's not going to delete that face. And you're going to end up with what's called an interior face. And interior faces, as we kind of learned from last week's problem solving bit, not good. You don't want interior faces. So what we have to do when we mirror across our mesh is to delete half of our model. And this is why the mirror modifier is so powerful, and it's why it's the first one I'm going to teach you. It's because you are literally doing half as much work. I'm lazy, you're probably lazy, you probably might as well do half as much work. If we get into the nitty-gritty of things, let's say I have something that has multiple lines of symmetry. I could do a quarter of the work. If it's something that mirrors on 8ths, I could do literally 1/8 of the work, right? Imagine modeling something 8 times as fast as you otherwise would. That's basically what this is going to allow us to do. So if I take a cube, right? Plain and simple. If we mirror it across this axis, right? And this axis, what I'm left with that I actually have to work on is just this bit. All right, everything else is just a reflection. Okay? And if we don't delete half of our models, like I said, we end up with those planes that are overlapping, right? So then you get into issues where you might try to move one part and then it doesn't actually go anywhere because it still exists on the other side. You just don't realize it because you can't see it. So we do need to delete our model by cutting it in half. Okay. So there's another quick example we're going to run through, but I've got one more quick demonstration bit. So if I create a cube here, I'm just going to delete half. Okay. Let's say I wanted to recreate a shape that is symmetrical for the most part, but not entirely. Okay. So maybe it only technically works on one axis, but parts of it can be done in two. What we can do is apply. So modifiers are non-destructive until you apply them. So you can, if I hover over this and hit Control A, okay, or right click the little thing here and hit apply. Right, so right now mirror modifier, this geometry is not real, it's just a reflection. We go ahead and apply this. Now that geometry is real. Okay, so I can model part of my mesh as symmetrical, and then I can get into details that are only on one side. Okay. Whoops. After I've done the bulk of the work with the symmetry. Right, so work on your big shapes first, do what you can that's symmetrical, apply what you've got, and then move into your smaller asymmetrical bits. This cube is a pretty bare bones example, but we'll do one that's a little bit more in depth in a bit. To apply it, you're going to hit Control A. So if I just add a mirror modifier here, or any modifier. This isn't just the mirror, it's any modifier. You hover and click Control A. So just like when I'm going to objects to apply, right? Control A on my object to apply the transformations. Control A, apply rotation and scale. I'm hovering over this and hitting Control A, and it will apply. You see it disappears from the stack. This is a bad example because I'm not actually mirroring anything, but there you go. Apply, and now it's all real geometry. So this also works if you make a mistake on half of your mesh. You can quickly, let's say I botch something here. I want to come in here and make like this circle, maybe, and I'll just extrude it, and then, I don't know, sure, something like that. And on the other side, we'll kind of do the same thing, just make a circle and extrude it. Except at some point along the way, I accidentally mangled this, okay? Right? Oops, how'd that happen, right? Instead of trying to recreate the work I've already done, we can just delete the half that we don't want, add the mirror, right? Apply it, and keep going, right? So now we have way less to rebuild than we would have otherwise. Okay? So there's a quick example here as well. I want you to get familiar with this and just try building some things. If you go ahead and add a cube, right? So I've stopped with the hotkeys for this. I'm just writing add cube. You should know by now what to do to add a cube, right? Control R we'll use to make a loop cut, right? And if we let go of Control R and right click, we'll just drop our loop cut in the center. And the reason it's good it's in the center is because it means we can quickly and easily delete half of our mesh. Right? So I've got all the hotkeys in here. We can hit Z to switch to wireframe view, which is going to let us just select half of our mesh a lot simpler. If I have a mesh that's very dense, let's say, like maybe I subdivide this a bunch of times. Okay. Might be a little bit tricky to get in here and select everything. I have to kind of go through and select. I'm going to hit Z to switch to wireframe view, and now I can just select through my entire mesh and delete the entire half. Boom. Or in this case, I can also delete the entire bottom and the entire this part. And I can just take this 1/8 and mirror it over all over, and now I've got a cube. Okay. So now if I, let's say, make a little chip in the corner here, it applies to all the different corners, right? Because it's mirrored over every which way. Okay. So select half the mesh, use X or delete to make a loop cut, and then go ahead and add the mirror modifier. There are two ways to get to the mirror modifier. In the slides, I believe I'm hovering over generate. And you can find mirror under generate because it is generating new geometry. So any of the modifiers that are under generate are going to generate new geometry. You can also just go into the search, which is a lot easier. Just click search and then just type in mirror and it'll pop up.
Marcus,
Yep.
just a question about modifiers and like modeling and stuff.
Yep.
Like sometimes I want to just shoot battle a corner, but I do not want to like bend the others. How can I select just the corner and choose like just one part? Because if I just like one, it doesn't let me battle with
Using the modifier or just in general?
in general.
In general? You can always kind of select one side. I might postpone this till the end after we've gone through everything, but if I was to take a cube and just split it up here, if I bevel this like this, for example, is that kind of what you're...
No, like just like one, like go to the vertices,
To the vertices?
and like just like a corner like this.
Oh, a corner like this.
Yeah, yeah,
Like that?
yeah.
Generally, I'd avoid this because you're creating really bad topology most of the time. But you can do it by hitting V while you're beveling.
Oh.
So V will switch it to vertex mode, and it will bevel the vertex instead of the edge. Yeah, so if you wanted to make like a chipped corner on a rock or something, you could do it this way. Yeah, but it's very easy to quickly create bad geometry using vertex beveling. So the better recommendation would be to sort of do the entire edge if you can, and then sort of start to tweak the individual parts. So maybe we move this around a little bit. Yep, no worries. Okay. So I'll give you a little bit of time here to sort of get familiar with the mirror modifier. So get used to moving things around, seeing how it affects different parts of your mesh. Maybe like 4 more minutes. Right. And then there's a little bit more after that. Then we'll talk about the weekly activity, and then I'll go over creating a live example that will use all of the things we just talked about. I think I'm going to make a drill. I think it makes sense. Trying to find objects that use specifically the exact things I've taught that week is proving to be a challenge, but I think this week it's okay. So I'll pause the recording there, and then I'll come back to this in like a few minutes. So we'll get back into things. The last thing I want to talk about is less related to modeling. It's not even something you really need to worry about too much. It's just something I wanted to get across now because I know people go and explore and start learning on their own. I just start recording, right? Yep. I know people like to go and explore on their own. And the issue is, if you're unfamiliar, you'll dive deep into Blender rabbit holes. But I want to remind you that Blender is just the tool we're using to make game models. We're not making models for Blender, which is where a lot of people might get caught up in their learning. So there are a few things we need to know about, and that's exporting from Blender as file formats that are okay for game engines and other things. So if you're working on your GDW games, you're going to need to know this. Generally speaking, we have 2 that we're going to use, being OBJ and FBX. You can access them from File, Export, and then you have Wavefront, which is OBJ, and FBX, which is FBX. Okay. I'm just going to quickly talk about the differences between the 2, why we export from Blender, that kind of thing. So OBJ is what's known as JSON style file format, meaning that everything is written in plain English and can be interpreted in English. When I was taking computer graphics, we had to write our own OBJ loaders and image renderers. I don't know if you guys still have to do that in OpenGL and C++. No, you don't. Okay, well, just know that you can interpret it with your brain. Like, you can literally read it. If I open a file, you could figure out maybe what it is just by looking. If it's like a default cube, it'll just tell you the position of all the vertices. FBX, on the other hand, is binary, which means you can't interpret it, no matter how hard you try. Writing an FBX interpreter is a whole other thing, right? OJ files are slower because of this, but the readability helps with two things. One is that they're mesh data only, or it's a lot easier to figure out where your mistakes are. Maybe it's not rendering properly in your viewer. It's a lot easier to hop into an FBX, or an OBJ, sorry, and see where things might be going wrong. The other thing with OBJ is because they're mesh data only, when we're doing things that require only mesh data, right? Maybe we don't want to export textures with our object because they'll get muddied up in the game engine or something, right? We have too many references to materials. We can export the OBJs as just geometry, which is great for baking and other things that we haven't learned about yet, but mesh data only. FBXs, on the other hand, have all kinds of other information, including storing materials. So if you add a material in Blender, it will store that material slot, not the material itself. And I want to make that very clear. It's storing the material slot. So what does that mean? If I give a cube an object, if I give a cube a material, okay, material.001 here, when I export as an FBX, it's going to export this material name and slot, and it's going to attempt to export all of this stuff down here, which you're not familiar with yet, but we'll learn about it in coming weeks. Color, metallic, roughness, blah, 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 blah. If you start Googling Blender tutorials, they're going to introduce you to this thing called shader graph, and that's what you're going to use to do your texturing. That is not how it works for games. Do not use shader graph for games because this is Blender specific. FBX files or OBJ files, neither can export this information to your game engine, okay? We have to use external textures. Lucas.
Sorry for asking. I personally would say if you want to use, I think you should use because it's really nice and it's a way that you should just be what you're shading. But you can export textures on Blender using it.
Technically, but we're going to use Substance Painter the way industry intended. So don't worry about that too much. So yeah. So when we export, we're going to use one of these two file formats depending on the situation. FBX is the easier one. The other thing you need to do, just throwing this out there now, again, kind of unrelated to what you're doing now, but is anybody making models for GDW projects yet? Okay, never mind. You are going to need to know this. If you're working on GDW, chances are you are not working by yourself, right? You probably have another 3D artist on the team also making models. Here's the issue. If I go and export this as an FBX, which is what you're all going to be doing for your game engine stuff, okay, we have a bunch of settings, which is great. That's fine. We want to be flexible. If you and the other person on your team have different settings, your importer in your engine is going to blow up. This is a super common problem that I see in teams in GDW all the time, okay? So I don't want that to happen to you. Find your team, pick settings that are consistent now. Don't do it later, do it now. I'll show you how to make a preset so that you can use it every single time. So first and foremost, we have this option, limit. So actually, I recommend you open up this window. This isn't in the slides. I'm going a little bit more into detail. I didn't realize you guys were already creating models for GDWs, so I didn't go super in depth. But you and your team right now should open up Blender File View, right? Go to File, go to Export, hit FBX, okay? And we have a bunch of settings. First thing we're going to do is check off selected objects. So this means that whatever we have selected in our scene is what's going to export to our file. This way we can have all of our objects more or less in one file. So something you might have been doing for GDW is like building a lamp in one file and then building a garbage bin in another file and then et cetera, et cetera, et cetera. It should all be in one file. There's really no reason for it not to. When it's all in one file, you have easy scale reference to make sure everything looks good together in scene, and a bunch of other advantages, right? So, you know, we could put like, here's my, I don't know, garbage bin. And then here's my lamp post.
Alright.
Okay. And we'll just leave them in the same spot here.
Sorry.
Yep.
Quick, I have an inquiry.
Yep.
So I actually do have a reason of not putting them in the same file, but I want to get your thoughts on this.
Sure.
So in Unity, if you just create a blend file and you put that blend file in Unity instead of like importing it through FBX and stuff, you get the model that you can put in the scene, but you can also live updates to your changes in that blend file. What are your thoughts on going with this workflow?
Don't do that.
Don't do that. Why?
And the reason is pretty simple. Is that as soon as you get into industry, they're going to tell you exactly to not do that. And you're going to have to relearn how to do all of this anyway. Because they have their own pipelines. They have their own model importers. They use standardized ways of doing things, right? Maybe it's a Maya project file at the absolute most, but it's not going to be a Blender file. I can guarantee you that. The other reason is because the Blender file is binary, it's ambiguous. So it comes back to that issue of I don't know exactly what information is being passed along. I don't know how much extra data is in that Blender file. If I add that whole Blender file to my Unity project, it's making my Git repo probably larger. I don't know what information is in it and what's actually getting built into the final game at runtime, how much extra space that's taking. When I profile things, I can't check exactly what's going on from that file when it's all combined in like a big blend file. Some people will make like an entire environment in their Blender file, just chuck it into Engine, right? But then also culling. It just becomes an optimization issue, more or less, right? If it's all one object from a blend file, you can't cull it. So when your camera's facing another direction, it's still rendering in the background, which is just wasting resources. So all in all, generally speaking, you're going to want to get used to exporting as FBXs anyway. To keep it quick, what you can do is just go to File, Export, and if you right-click on any of these options, or any option in Blender, I should say, it'll ask you if you want to hotkey it. Okay? So for FBX, I use the hotkey real quick here. I'll just change it. Control, Alt, Shift, and F. So there's nothing by default on Blender on this. That's why I use it. It's a lot of hotkeys. So Control, Alt, Shift, F. Right? F standing for FBX. And then for OBJ, I go up here and I do the exact same thing, but with O. So export, OBJ, right-click, assign, Control, Alt, Shift, O. Okay, and now if I hit that, it just pops up my export window. So yes, it does take a little bit longer than just updating your blend file live to re-export it every time. But once you've exported it once, you just have to click on the same object to rewrite the name. Export, done. Takes like 2 seconds. Okay, so let's continue with these settings. So this is what my blend file looks like. I've got my lamp in it, and I've got my garbage can in it. Control-Shift-F. I've got my garbage can selected right now, but not my lamp. We're selecting selected objects only. And for object types, same reason as the other optimizations I was talking about, we're going to go to mesh specifically. I don't want to export my camera and stuff right now for you guys. I just want you to export the mesh as it stands, okay? As we move down, transformation settings. This is a bit of a contentious one. Different things use different axes. So in Blender, for example, Z is up. But in most game engines, Y is actually up. So we can use this to convert it, but generally speaking, I just leave it as default. And if I need to rotate something 90 degrees in Engine, I'll rotate it 90 degrees in Engine. For geometry down here, I'm going to change smoothing to face. There's a computer graphics reason for that. I'm not going to explain it right now. Just know it makes your things look better, and the smoothing groups will apply better. We can leave apply modifiers on to make sure that our object ends up the way we expect it to. And last, triangulate faces. I'm probably going to also check off here triangulate faces to make sure that when I import it into my game engine, it's already triangulated and there's no ambiguity. So any of my n-gons on export will be triangulated, which leaves no room for the engine to mistake something. Okay, that's it. The other things you can do is get rid of like animation because it's not animated, right? So this is for static meshes, right? So all these settings we just made are for static meshes. There's no armature, there's no bones. It's just a mesh that we're using in the environment. I'm going to go up to my operator presets, and click this little plus. Is everybody with me still? Okay. I'm going to go to operator presets and click this little plus, and it's going to ask for a name. Okay, so what I would typically recommend you do is name this your project settings, right? Because you might be different project to project. So in this case, I might say Unity underscore Jam-Packed is my indie studio, right? Underscore SM for static mesh. That way I know when I click this, I'm exporting a static mesh the same way as my teammate on Jam-Packed for everything. Hit OK. And now you can see it pops up. You can see I already have a couple. Library project from a project I was working on that was a library. Sedna Unity SM from when I was working for a team called Sedna. And then Unity Jam-Packed SM is the one I just made, right? So every time I go to export from a fresh file, just press this, Unity Jam-Packed SM, it updates, right? If I change this to library project, it's going to update for Unreal. SM, export, right? So I can name this garbage bin SM for static mesh, and just export to my desktop, for example. Okay. And from my desktop, we can open it up and see it's just a static mesh. Oh, FBX file is not supported apparently, actually, never mind. Okay. And then I would select my lamppost and do the same thing, except this time it's called lamppost. Okay. When you export, it's going to export as if 0, 0 is the origin. So that's why I'm moving everything. So from over here, if I export this, the origin point in Engine is going to be over here still. So we want to move the origin point to where it is, and that's why we're using Shift-S to move everything. So you will end up with a bunch of models just on top of each other in your file. Totally normal. As long as your file is organized, it's okay, right? So I might have these in a collection called environment objects. And then I can quickly get rid of them when I'm working on something else.
I thought you said the object origin is what determines where it gets placed.
In Blender. But once you export it for your engine, then you do need to move it back to where it, like 0, 0.
We want to put our object origin at so if it's a lamppost, we want to put it at the base so that after we're done modeling it, we can move it to the origin easier.
Yep. That's pretty much it. Or if you want to, even if you want to scale it in Blender, right, it'll scale from that point, which just makes it easier for certain things. Right? But also this, I can model it somewhere else so it's out of the way and then move it back into place before I export it. Right? And I can just work on this by itself. Okay. So then if I want to update any of these models, let's say I want to make changes to this garbage bin, maybe I want a little bit more detailed of a lid here, we'll just kind of bump this up. Fantastic. I can just quickly hit that hotkey we just made. Boom, boom, click on the one, export to overwrite it, not that. Okay. So once you have these settings, picked, get with your teammates, make sure you're using all the same ones, and create a preset, okay? Otherwise, you're going to run into issues all year. So that was kind of a big aside, because I didn't know you were already working on your GW models. The last little bit here, shaders. Right, so like I was saying, these shaders are not transferable. What we can do is this process called baking, where we bake our shader results down to textures and export them. But we're going to be doing that in a program called Substance Painter that's actually designed for that. So that'll be coming up in the next couple weeks. Yep. Jason.
Do we have to do this again for
You're going to be using FBX if you're importing it into like Unity or whatever else. OBJ was more for, I wasn't sure if you were doing CG and had to write your own stuff. Like when we were doing our computer graphics in second year, you had to write your own engine from scratch. So FBX is really hard to do. I don't think you guys are doing that anymore, so I don't think you need to use OBJ really that much. The presets are different, yeah. The OBJ one, you'd have to do something similar-ish where you're just making sure you're consistent throughout the team. That's the big thing. Okay. Everybody cool with that? Everybody kind of got their settings worked out? Everybody going to share that with their teams so you're not coming to me in like 3 weeks and going like, Marcus, when we import my models and my teammates' models, they're different sizes than they're supposed to be in the file. That's why. It's going to be those export settings. Okay, cool. Last and finally not least, activity number 3. So activity for this week is going to be a mirror modifier exercise. I want you to pick a prop, explore finding lines of symmetry in that prop, and building something. So if I quickly open this up. I just made a switch really quick in like 10 minutes because that's all the time I had before I posted the assignment. But if we go here, mirror modifier, you notice the submission format should be quite familiar to you by now. The way that we want to kind of highlight which parts are broken up is all familiar to you. So real quick, just find an object that you can think of, break it down with those lines of symmetry, move your origin point using Shift-S and snapping to where it needs to go, and then model one half of the object. So it pretty much wraps up all the different topics we covered today into a nice little package. Maybe I'll make another switch just for example sake, maybe a drill, I don't know, we gotta find something. But we'll go through the entire process now together, but you're free to sort of work on it on your own. And Josiah will have some more time with you on Thursday to sort of go through and make something as well. Oh, sorry, Josiah will not have time this week because this week is that lab assignment 1. So I would recommend using this time for that. Before I get started on the live example though, I'm just gonna come around to answer any final questions for the assignment 1, that being the chisel. If anybody wants me to review theirs or take a quick peek before I start the live example bit. All good? Okay. Yep.
I just want to be so I mirrored the 2 sides, right? And I used the pencil as well. And then I just had I did like a array fire. Would this be good, or should I? Or what else should I add to this? If I'm
But yeah, I think it's probably a little bit. I really want to get excited. You could wires and things like that. That's not necessary. That's just if you want to.
so electrical box that we got.
Electrical box would be good. Okay.
You come here when you finish the class. So I finish the class, sorry if not. Because you asked me to say like, hey, when
So-
you finish, you ask about the Ubisoft stuff.
Yeah, sorry. I can't give you grades for it in this class because I didn't set that up from the get-go. But what I can do is what I've told all my other students as well. As you work through it, you just message me about it. I'll give you direction or help in any which way I can find it. And I've got some.
Well, I'm honestly, to be so honest with you, I'm not looking to get grades from it, but sure. If you can actually just give me help and like give me pointers, that would be amazing.
I can give you a ton of help, and I'll just get into. I'll give you the rubric for their final assignment because their final assignment is. Well, that's mine. There's not.
Yeah, no,
expected to
that
be
is
as good as
amazing.
that.
Wow.
Their stuff is this is the same stuff that
Yeah.
Ubisoft is looking for. So my rubric is just Ubisoft rubric. That's how I've done it.
If you can
for
just
them.
like send me on Discord, that
Yep,
would be great.
I'll send you this. I'll talk to my people at Ubisoft and also like
Your people, damn. Sorry.
yeah, no, my people-ish. And then
Yeah, no, I'm just messing with you,
there's an
sorry.
example. It's all good. I've got example submission here of a previous. This was Andy, my friend.
Yeah. No, right now I think Ubisoft next team is Secret Passage or
Yeah.
Hidden something.
Yeah,
it's Secret
Secret
Passage.
Passage. It's Secret Passage.
I don't know if
It has
it's
to be
super cheesy,
interior.
but I was thinking of doing like a brick wall that goes like out. You know?
Yeah, it has to be an interior though. Just
Yeah.
the exception. But anyway, yeah.
It's
so
a 1x1 interior, right, or 2x2,
yeah,
something.
this
like
is
that.
how I'm expecting the third years to submit.
Yeah.
And it's the same thing. Like I need a fly through of their scene. I need breakdowns of how they kind of did things, and it's exactly the same stuff that Ubisoft's looking for.
Got it.
So I'll send all this to you as well.
Thank you
if
so
want to
much.
participate. Yeah, nice.
Yeah. You have my Discord, right?
I do.
Okay. So thank you so much, Marcus. Have a
Take
good
care, Lewis.
weekend.
You too.
Have a good week. Sorry about you.
What's up?
So I just got a question. It's not exactly about the assignment. It's about one of the other things I'm working on for GDW. So I guess this isn't really important, like everything going on here. So, basically, just what I need your help with is there a way to maybe render like a little, like fire? Actually, no. Now that I think about it more, maybe that'd be easier to just do in Unity. Basically, this is going to be the title screen for a game. That's why these chess pieces are so high res.
Yeah, I was gonna say do it in Unity.
Yeah, because I have a transparent PNG of this rendered with like red underneath it, and the whole idea was going to have like a little flicker at the bottom. I think I'm just going to do that by applying a light source directly into the image and then just having it blink.
Yeah,
Right, never mind.
no, I'd probably do that in Unity because then you can also make it interactive, like load all the 3D models. If it's the only thing that's in scene, you can go as high res with that stuff as you want. And like, yeah, it's not going to be a render issue because there's not like there's any gameplay that's actually happening, right? So, somebody suggested something to me for a different GDW game they're making where they wanted the level to be visible from the menu and like interactable in a way you could plan out your.
Oh, that's
Granted, your game, if it's chess-based, I'm sure doesn't need that level of meticulousness, but just like even just the ability to flip around while it's there in the background might be something looking into.
That's a neat idea. Alright, anyways.
Unity's probably better for that, don't you think? Plus, you're so familiar with shaders. It's after last year.
Anyways.
Cool. Yep. Yep.
You see that, or do you see like? I mean, I see it now. So I think like that's what makes most race. That's what he said. She was like, "That's who wants to run space." And then I heard these little. Yeah, I was like, "Oh, this look good."
Division,
Oh, how do you feel? I like the mission too. Yeah, maybe not ultimate because like when I'm thinking of like space chairs, I kind of like especially ones with like higher more ergonomic chairs. I'm like, I'm gonna try. Okay, so more like okay. Oh. Okay, yeah. Because like you're gonna be, because my thing is, it's only maybe like logistically, so going into hyperspace, you're gonna like form it. And if you don't have a big backpack, you're gonna have a big chair back. Yeah. Okay, you know what? I like this is. It's not like really relevant for obviously aesthetics matter more words. No, but I did 3D later. This was like my first iteration. Yeah. So like, you can just try and like raise these up. Okay. Oh my god. Is it not going up on the right axis? Yeah, no. Okay. Yes. I was so bad at doing my packages because I was trying to like this sometimes I have no idea what to do, but sometimes I was like do stuff and then I try to loop cut and then you'll look across every single side and then I have to have my fix this. So I just have to like go back. And then of course I don't need to do it. I keep saying guys, see in my head, do you see how there's like an extra notch there? So maybe notch, and I can pull that back on.
Oh, I don't know.
As in like, you know how these go I think I might just delete this. But I'll make these shirts very different. I don't want to Driving in a hyperspace.
Wait, why completely right. I definitely see what's going on. In fact,
So there's like one of those spaces.
oh, we can be able to take on.
If they're into gray, would they like consider Okay, I'm gonna draw what I'm and then I'm just imagining
Don't worry, we're inclusive.
so this is all I'm imagining right now.
So that make it a sphere.
It looks a little weird when I take away the. Oh yeah, you can.
Okay.
I did too.
That's a layer.
Oh, did we open it?
That could be a tongue. That's kind of funny. Okay.
Select spaces.
That's not okay. I like the fish balls. And then so I want to try Scumpus.
Hello? All right. So for the exercise, same old, same old. Once you get in, go ahead and use the, oh, my screen's not on. That's why. Once you get in, go ahead and use the random color option in the overlays. So up in the overlays, random color, just so I can tell how you broke up your mesh for the submission. So same as last week, it helps me sort of see how you're breaking things down. So you see the different, they're almost the same color, but they're slightly different. It just helps me see how you're breaking things down. So same submission. You should be pretty familiar with this submission format by now. It's been the same basically every week. Okay, so let's dive into some form of live example. I've got we didn't take a break really, so I'm not planning on going straight to light. So let's just say 30 minutes here. Let's see what we can do. I was trying to think of good things that use mirror modifier. Maybe a drill might be something to work from. So you can, yes?
Since we're all allowed to use the ones Josiah does tutorial with us for our submissions, if we finish this on time, will we be allowed to submit this for the activity, or do you want us to do something else?
No, of course. Yeah, this is this is the part where it's okay in the lecture to follow along. I think this is the part where you should be following along more so. This stuff works, and then because this week especially, you won't have time to do the weekly during Josiah's in-class assignment. So I'm gonna do a drill, or at least like an approximation of a drill. You guys can go in and add more details later, but we'll do something like this, I guess. I won't get into all the nitty-gritty details, but we'll start by how we break down our reference. So first and foremost, I'm just gonna open up a Pura file so I can look at this. And we'll drag and drop. So we've got this file, might as well keep it and use it. And for now, I'm going to get rid of the randomness. Okay. So let's take a look at this drill and think about how we can break everything down. So the first thing I'm looking for is symmetry. Where can I make this symmetrical, right? And from this picture, it's not super obvious, but I know, because it's a drill, that from the front on, so along this y-axis, we can have some symmetry, right? The other part I know is it's all roughly going to be one piece from here. So I want to start with this cylindrical part. So let's go ahead and hit Shift A and add a new cylinder. And like I've kind of been teaching you guys this whole time, we're going to start with a low number. Low is easy to work with, so I'm going to start with 8. Okay. I'm going to quickly rotate this 90 degrees on X. This way I get my barrel kind of facing forwards. So from the front, we know we have symmetry. Let's get a second reference, maybe. Maybe there's not enough reference. We can grab sort of a second one. It's not the same, but we're still just looking at how we can build this. Failed opening. Must be WebP. Kind of hate that. There you go. Learning to use reference is another key thing. It's something you should have kind of been doing this entire time. It is going to become even more important later. Next week, we're going to be building a prop from scratch. So you'll kind of be expected to design a prop and then build the prop, as opposed to creating something that already exists like we've usually been doing. So I just want to get maybe one more from like the front. The least like imagining we're doing in our head, the better off this will always turn out. So something like this maybe, just to get an idea. This looks more like an impact wrench, but we'll go with it. Okay. And we might combine different elements of this as we build our drill. We're not necessarily recreating one in particular, but we know we want to start with this cylinder. Quickly here, I'm going to use that little technique we used earlier and use J, okay, to create some new edges. J, create some new edges, and I've got some nice quads to get started with here. And then I'm going to kind of just shrink everything down close-ish to real-world scale, right? We don't want to be working on our objects at random scales. By default, this cylinder is like 2 meters big, which is huge for a drill. So I'm just going to shrink it down. Not to an exact amount, but just roughly here. We know that, maybe 20 centimeters is the right size for a drill. So let's start there. Control A to apply my scale so I don't get any weirdness later. And we're good to start working. So the first step is going to be to add a mirror modifier. Okay, so I'm going to tab into edit mode, use Z to switch to wireframe. We've already added these extra edges, so I can just quickly select half of my mesh, X, delete. Okay, I just want the one half. oops, go to my modifier panel on the side here. I'm going to type in mirror and then add a mirror. So by default, it already uses the x-axis. So we're good. It's mirroring from this side to this side. Okay. But right now, if I move this around on the x-axis, it's not actually connected. So we're going to turn on clipping to make sure that it stays connected in the center. Okay. All right. So I'll pull this back over. And I hit 3 on my numpad to jump over to the side view. And we'll kind of move this into place. So I'll just move this up somewhere here. And we're kind of just trying to match the shape. So we'll move this up a little bit more. I'm going to use tab to go into edit mode. Z to switch into wireframe. Okay, so I can select through this entire front bit. All I've done at this point, right, just add the mirror modifier, basically that's it. I haven't really done anything else. If I switch to the side view though, it's a lot easier to compare my sizes. So I'm going to hit G to move my face, Y to lock it to this axis. So now we're moving this face. And I'm going to move it out to where I think this sort of bit would end, because it looks like this could kind of be another object that rotates. So I'm imagining a center line. All right, so if I use this really quickly, I'm just kind of imagining it's going to split into a new object right here. Oh, that's too big. This is going to be one object. This is going to be one object. This is going to be one object. Running out of colors. And we'll model the rest of this as kind of one object. Okay. So right now I'm just worried about this part. So we'll pull this back over. GY to move it back a little bit. Nothing needs to be perfect. We're just sort of roughly putting things in place. And I might move it up a little bit as well. Just leave us more room for the handle. Right, but we can always move it up more later. From here, I want to build this second part, the spinny part, this green part here. So still from the side view. I'm going to select these front two faces using face mode. I'm going to hit Shift D to duplicate them. So now you can see I've got a duplicate of those faces. Without deselecting those duplicates, so I'm still got them selected, I'm going to hit G and Y. And so let me just move it off to the side for now so we don't get it messed up. Okay. Because we know the connection between this piece and this piece is going to be the same size, so we might as well make use of the mesh we've already created. And now I can hit P. We learned about P last week. So P is going to separate this selection, this front bit. I'm going to hit by selection, so just the part that I've selected here. And now it's a new object. So I've got my original cylinder and a new object. So this is going to be my green object. Okay. So I'm not going to worry too much about these details for this example, but now I'm going to do the exact same thing we just did for the other piece for this one. So we'll move it roughly into place. We're just kind of blocking things out. And I'm going to extrude. So I use E to extrude. And we're going to just kind of go to this point. Still looking at the reference. And then I'm going to use S to scale. It's going to scale down just a tiny bit. We can see here it scales down a tiny bit. Nothing crazy though, just a little bit. Okay, slightly adjust it here and there, just so the proportions are right. I'm going to follow that exact same process again for this next part, right? So we have another part here that's kind of coming out, except this part's in, right? It's not coming out at the exact same silhouette. It's coming out a little bit inwards. So how do we get that inwards bit? We can inset. Okay, but by default, inset is going to inset our entire selection. There's a hotkey we can press inside of inset. So if you look here at the bottom of the screen, this is something I've never really mentioned before, but at the bottom of the screen, all of your different tool options pop up, and they're hotkeys. So if you're ever confused and want to see more about what a tool might be able to do, it's right here. So in this case, we have boundary. So you can see B, boundary, and I, individual. So if I hit I, individual, it's going to inset each individual face. And you can see it lights up there. Hit I again. If I hit B, boundary, it is not going to create an edge at the boundary. So any edge that is not connected to anything, it will not inset that, right? So now I'm insetting towards my mirror instead of having to do this and then reconnect it afterwards. So B for boundary will remove that part of the inset. Okay, this is very useful in all kinds of situations. Another situation that might be useful, if I add just a cube to the world, all right. And let's say I want to create an inset that's like a door, right? You would normally like do this, delete the bottom face, grab this edge and move it down, make new loop cuts, yada, 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 yada. Or if I don't have an edge here, if I create an inset without a boundary, it won't create one on that bottom. And now I can make a door. So once you hit I, before you let go of it, so press I, don't click or anything. And then at the bottom of your screen, see B for boundary or I, for instance. If you hit B, it'll change the boundary. If you hit I, it'll change the individual. Okay. So once we have that, now we can duplicate this face. Again, just like we did for the other cylinder, and move it out. Okay, and do the exact same thing, P, separate, boom, right? Because we're doing the exact same thing. So now, again, we'll kind of move this into place. We'll extrude it out. This is now this barrel part. Get the approximate kind of size. And then same thing, extrude a new one, scale it down to get that second edge. Okay, so now we have something like this. Is everybody still kind of with me? Ish?
The reason we separate like this is because we want to avoid inside facing.
The reason we separate like this is it just makes it a lot easier to work on the pieces individually. So if these were all connected, let's say this part, for example. So don't follow along with this part. I'm just going to do it really quickly. If we wanted to create those kinds of details here, I'm not really looking at the reference. I don't really know what I'm doing. Let's just say this is close enough. I wanted to create this kind of detail here, and I need all these extra edges to do it. If these were connected, I now need to extend these edges somewhere into the rest of my mesh.
And when we piece this back together, and we like, say we added like bevels to each of those like little edges, and it kind of puts together, is that bad?
Not necessarily. Sometimes, I mean, that's kind of how this works in real life too. So if I was adding a bevel, I would get these like tight creases in here where the pieces separate. Whereas if this was one mesh, I would not get any creases here. And so to recreate that, I'd have to make a tiny little bevel like this, and then I'd have to extrude it. Oops. I have to like extrude it inwards like this to get that same crease, and it's all very tight and extra geometry. So not really necessary. It's better to generally just separate them if it's separate objects. Yeah. No?
Question. Suppose you did want to do a bevel like that. You wanted to have that detail
Yeah, theoretically. I haven't taught you guys about normal maps or anything like that yet, so I'm going to just leave it as straight modeling for now. For something like this, that would be like a hero prop, absolutely. That is something you would do. There's no reason to make such minute details on the actual model because they don't affect the silhouette of the model. So you could do that to optimize even further, is to reconnect this here and then normal map it. But for the purposes of this demonstration, we'll keep everything separate. But yeah, you are right. Yep.
Sorry, I'm like really behind, but
That's okay.
When I'm doing the inset, my boundary key isn't working. I'm pressing D and it's not doing the like automatic snap to the edge thing that.
Do you have the mirror modifier applied here?
Yeah, I have the mirror modifier applied. Am I not supposed to?
It is there. It should be there. So we select this. So make sure you have the faces selected like this. Inset. And then hit B.
Yeah, no, it's just not.
So if it's not working, then what's probably happened is you haven't deleted the face on the inside when we made the mirror modifier at the beginning there. So if I hide the mirror, if you have a mesh like this, for example, then it will include that in the boundary. So you could just get rid of the mirror, come in here, select the face that's on the inside and delete it. And then it should be hollow like this on the inside. And then once you get rid of those interior faces, it should work again.
Okay, yeah, there we go. Thank you.
Perfect. No worries. Okay. So we'll continue. GUI, separate. I already made this piece, but I'll just remake it quick. Still looking at the reference, making sure we're roughly in the right kind of scale and size. Right now, when we have such little geometry, it's super easy for me to make changes. So if I don't like the way something's looking size-wise, I can quickly come in and just move everything around. Okay, super simple. Scale things down a little bit. This looks asymmetrical. So this is one of those cases. It looks like I've accidentally made this out of circle at some point. So I'm just really quickly going to redo it. Because we're at this stage where it's super early on, it's not a big deal to just redo it quick. Piece, separate, GUI. Okay, cool. I don't know how it went out of square there. I must have accidentally done it on a different axis, but kind of move everything back into place. You can work on multiple objects in edit mode at once. So if I select both of these objects here and then go into edit mode, you can see I can work on all of them at once, which is helpful. Okay.
The middle part of the drill kind of like smaller. Whenever I try to copy that, I just end up resizing the entires of the rest of the cylinder.
The middle part?
Yeah, that one.
This one?
Yeah.
I just selected just this face. So if I have it extruded out by default here, if I just select this face and scale it down. Okay.
Oh, I extruded mine and separated it.
The other bit here is we can use scaling to the 3D cursor and moving our 3D cursor to the center to make sure it scales evenly across our mirror. All right, so if I scale, it'll scale from the 3D cursor. Inset, duplicate, move out, separate piece.
For some reason, it just keeps scaling with the entire cylinder.
Okay. Cool. I do want to push this a little bit, so I might speed up a little bit here just for a while. So Josiah in the lab taught you last week with the saw this idea of modeling from a plane. So that's one method, modeling from a plane. The handle, I believe, was a little bit more box modeling style. So the reason I'm focusing more on the individual tools and less on the overall structure is because, well, modeling from a plane is good for certain things. It is not going to be good for other things. For example, this drill. It'd be impossible to draw this as a 2D shape and then extrude it out, right? For something like this, we have to start in 3D from the get-go. So this version of modeling is called box modeling, where you start in 3D and sort of work your way up instead of starting with a cube. So we're following the same principles, but we're kind of imagining each individual part as the next plane to draw from. So here, if I imagine this from the front view, right, I know I'm going to have this smaller circle inside of this bigger circle from the front, okay? Which means I need another edge. So that's where this extrusion comes from. So if I pick these two and extrude it right now, right, it doesn't make a ton of sense, but when we scale this bit down, so I'm going to select my vertex, Shift S to move my cursor to selected, because I'm scaling at my 3D cursor. Now when I select these faces, I can scale this down, and I'm getting this separation. Okay, so everywhere you have a change in plane, you're going to need new geometry. Yep.
Are we still able to get this from planes? Because he showed us how to make cylinders with a plane. I think it was like a circle, and then he extruded it out and just added cylinders until it's circular.
It is, but that's essentially the exact same thing we're doing here anyway. We're just imagining that this part is our new plane, basically. So I'm imagining this next bit from here. This is my plane right now that I'm working with. So rather than having this somewhere else and then, you know, we're essentially doing the same thing, just with the geometry we already have. All right, so something we could even do, something that wouldn't work from a plane, but we can do from this is, I don't actually want to make these two separate pieces at the beginning. I'm going to make one big piece here. Because this is all one angle, if I separate it, it might be hard to get the exact same angle. So I'm going to just move this out. Make sure to scale it to the center. And so this is now representing this entire edge. Then we can loop cut the middle and wireframe select this bit to separate it. And now we know it's matching. It's got the exact same angle across the entire part, just like this part here, right? So if I try to do that by hand, I might not have been able to get the right kind of scaling down to make it look proper. So this way I know for sure it's going the right way. Okay. And then the last little bit is just the end of it, which it's going to be the exact same process. So I'm going to just bomb through this part real quick because it's the exact same process. So I'm just going to move this over. I want to apply the mirror to this one because I'm going to build it into the center. Separates. We'll inset this a little bit. I'm speeding through this part because, again, it is the same thing. So now we're just scaling this bit down. GY to move it into place. Cool. Okay. So all these cylinders follow the exact same process pretty simply. We still have the mirrors on these. So what I'm going to do now is work on the bottom part. So we have this handle that we want to connect to it. Right? So all of these have these handles that sort of stick out the bottom. And we want this to be one piece as much as possible. So we somehow need to create extra faces on the bottom here that let us build out. Right? We need to imagine this in 3D as we work. So if I was just to kind of come in here and grab this, I could theoretically just extrude this out like this and then down, and like boom, it matches, it's level here. But I've created a bunch of impossible geometry that wouldn't work in real life. Things have thickness. So instead, what we're going to do is make an extra edge loop here. I actually don't want it to go all the way around, so I'm going to click on this and hit H to hide it real quick. And I'm just going to get rid of our edge here, so we can add one just to the bottom. Okay. So now I have this extra edge. You can imagine the bottom of our handle here is going to come out flat. So I can use G, Z, and our snapping that we learned about to move this edge down. Okay. And what that's going to do is give us this flat bottom that I can then extrude our handle from. So I've added an extra loop cut here, right? G, Z with the snapping to move it down and create a flat plane here. How do you do? So Control R to add the loop cut. And this is just going to create a face along, an edge along these two faces. Right click to let it go, pops into the middle. If I use G, I move around, right? But we learned about snapping earlier. So I have my snapping turned on. I have active mode, so I know which edge I'm snapping. And I have vertex mode. And I want to snap to this vertex's height. So if I hit G and then Z, I'm doing the same as usual. So we learned about GZ where I'm locked to just the Z axis. But if I use the snapping now, I can snap to the height of any other vertice. So I can snap to that one, to that one, to this one. If I snap to the bottom one, we'll end up with this nice flat plane that we can start to extrude our handle from. Yep, no worries. Is that still catching people up? People still a little bit confused what's going on there? The cone, I just scaled the cylinder down. So it's just another cylinder, basically the exact same process. You could do it the exact same way you did these three. And then just at the end where this would have been flat like this, I just grabbed the end and scaled it down. Okay. So back to where we are with here, I'm going to add this edge loop again, GZ to snap, and now we have a nice flat plane. Okay. I'm not sure entirely where it's going to cut off down here. We only have like this one reference, so we're going to have to do a little bit of imagining, but something like this looks appropriate enough. We can do a test extrude. So I'm just going to grab this face and extrude it down, and the mirror will extrude on the other side for me. And now you can see we're kind of recreating this part here where the cylinder is going to combine with some flat surface. Okay. Now I need a part that extends outwards underneath the barrel. So I could grab this and extrude it. And we can see it goes out about yay far. Cool. I'm not going to worry about this little intricate detail with what we're doing right now. We can take another look at it and see, maybe this is too thin, maybe it's too thick. So I'm going to undo that quickly. And if we move this edge outwards, we can create a thicker handle. So I think that's what I'm going to do here. I'm going to make it a little bit larger and then just redo that really quick to just see how it looks. And this looks a little bit more proportional. So this trigger part we know is a separate piece, so I'm not going to worry about that. I'm just going to select everything and move it up because we're a little bit close to the ground. Okay. Now we have these kind of complicated parts to make. I've got this round part coming in on the back, and I've got this curved part in at the front. Okay. To do those, I'm going to need to add a little bit of extra geometry. And again, based on what you said, Jason, where you can kind of model these as planes, I'm going to think of it at one angle at a time. I'm just going to approach it from the side view right now, and then we'll go back and approach it from the other views. So what do I mean by that? I'm just going to recreate this using edge loops right now. So let's look at where we need more. So we want these to sort of extrude out as a handle. I'm going to just bring this down. And we'll, instead of building it up, we'll cut it out. So we're going to cut out this handle part. And we're going to cut out this handle part. So let's add some edge loops around here. We'll add a minimum amount first and just kind of go bit by bit. So we'll start with just like 4. Okay. So when I hit Control R to add the edge loops, if I scroll the mouse wheel, I can add more or less. So we'll start with something like this, for example. And now I've got more edges that I can use to build my shape. So if I go into wireframe mode, I'm just going to grab this whole edge and use axis locked moving to move it around. So we'll move it to that first kind of edge here. And then if I select this vertice, I'm going to kind of move it into that gap. Okay. Now I drew out the handle, right? But you'd be visualizing this and comparing with your reference. I know this isn't even accurate. This is supposed to go in more and this kind of builds out. So I'm just moving a few vertices around right now. This part's should be pretty hunky-dory. I'm just trying to match this shape more or less. Okay. And then I'm going to do something similar in the front. So I'm just going to take the vertices that we already have and just kind of move them into place. Okay. But then we run into a couple issues, right? So here, if I try to move this vertice back and forth, so G, Y, if I move it in to create this underhang, that's when we're going to start crashing into ourselves. So this is where we know we need more geometry again. Okay, so let's delete the outside geometry. Just deleting the faces. So drag, selecting, deleting the faces. If I add a new edge loop here, it's going to kind of go throughout the entire model. And that's not necessarily what we want because that's adding a bunch of extra faces and everything else. So what I'm going to do here is just temporarily for now kind of move everything in. And as we build up with more geometry, we'll come back and revisit that shape later. But for now, we're just kind of trying to block this out. Okay, and I think I need to extend. Yep.
Sorry, can you go over how you did the wireframe cutting again?
If you hit Z, you can switch between solid to the right and wireframe to the left. The main difference between them is just in solid mode, if I was to drag select these edges, it doesn't actually select the other side. So if I move these now, I'm not affecting these ones in the middle, but I want to move the entire edge. So in wireframe, when I select these, it's going to select right through.
Right, no, but I'm asking, like, how did you do the blue line cutout?
Oh, I just drew it. That's not the blue line bit. You'd just be imagining like what the shape of your object is as you kind of go through it. I drew that just to kind of visualize what I'm thinking about when I'm making the cuts there. As far as adding the actual cuts, I just added them with Control R and then scrolled up to add a few extra. Some of these will probably get deleted in a second anyway once we look at it from the other direction, but this is just, we know we have the kind of shape that we're trying to block out here. Okay, so I'm going to revisit my proportions a little bit. Scooch this out, scooch this out. And let's get this bottom part where the battery would connect. So scooching this down, scaling this down. And now I'm going to extrude and scale out. Okay, just moving things around to, again, I'm working on this battery part now, so I'm just kind of matching the shapes. And we'll do something like this, just roughly. Okay, I've accidentally deleted a bunch of faces in the middle here. I didn't mean to do that. I don't know when I did that. So what we can do with the mirror is I'm just going to select along this entire edge that we made. And if I extrude it now into itself, so extrude it on the x-axis, when I hit the middle, it's going to clip into itself because we have clipping turned on. And now it's merged at the center, right? And I can follow it up just by selecting everything, hitting M, merge by distance. Okay. So now that we've worked on it theoretically in the one axis, so we know from this side view it's looking decent, then we can kind of go at it from another axis. So we can start to add loop cuts the other way. And sort of, we know this handle would be kind of round-ish for, you know, so you can hold it comfortably. So I'm going to grab the middle part and just kind of drag it out to make it a little bit rounder. Okay. We can grab this back edge. I'm going to go to the top view. Just move it in a little bit to make it a bit rounder. And the same for the front. Top view, move it in and make it a bit rounder. Okay. Now that we have a bit more geometry, it'll be easier to come back to this part that we didn't quite do. So we know we've got this little lip here. It actually looks okay. We'll go underneath this part here. Right, we want to make a new object that's this trigger. So I'm going to do the same thing I did for all the cylinders. I'm going to duplicate it. I'm going to hit P. And now I've got my separate, what will be the trigger in a second. So I can select it and extrude it, scale it some more. And I've got a shape that I can start using for the trigger. So we'll drag this down. Move this up. Okay. Now we have something that we can roughly call a drill. It's not fantastic by any means, but it's just the idea of a drill, right? And once you have a block out like this, you can continue to polish it up in different ways, like adding the more specific edges and bevels and breaking things up in different pieces. But for the purpose of weekly activity, this is enough. This isn't good topology or anything. It's just a quick way to block our shape out. So the last thing would be to go shade auto smooth to make sure our parts that are supposed to be round are actually round. So right click, shade smooth, and I'm just going to up the angle to something much higher. Shade smooth, let's just say 60. Shade smooth, 60. Maybe like 48, 45, 30. Okay. Another good example. Here we go. Right, so if you have something like this now, you can just go into color, select random, so I see what parts are separated. Hide your overlays and take your screenshots for the weekly. So clearly, we're a little bit lost at some parts. Sorry, I had to hurry up there at the end because we did end up getting pretty close to 8 o'clock, so I was just kind of blitzing through that last bit. It'll be in the recording for sure. As far as actually making the structure, I believe what probably was confusing was the handle bit, because we're adding a lot of new geometry. You sort of just have to imagine every piece is a new extrusion. So if I go all the way back here, so if you go to edit preferences and then sys system, you can up your undo steps to 256. I'd recommend doing that. So it's under Edit, Preferences, System, 256 is the highest it goes. Yeah. So another thing, this last little note, we're kind of over time now, but I'll just kind of demonstrate what was going on in my head when I was making that drill bit, the handle part specifically. I can't put you inside of my head for you to understand what exactly I'm seeing, but if I do it like this, it's the closest I can get. So let me just drag this in here. So you can drag images into Blender like this. So if we go something like that, we can also see my proportions were off, but that's okay. What I was doing is we're imagining each one of these. If I move this to where roughly the handle is, just say like here. We're imagining that we're just extruding downwards and then scaling on Y. Because if we just scale, it's going to scale on all the axes, right? So it's going to get smaller. We don't want that. We're just going to scale on Y. And now you can see where I'm kind of coming from here. So I'm selecting the edges that we extruded, and I'm just moving them to the silhouette of the object. So if I extrude another layer now, kind of doing the exact same thing. So just taking this edge in the back, moving it along, right? Hence the name box modeling. So I just did it as a bunch of loop cuts because it's a lot faster than extruding it out every single time. But you know, right now I'm just worried about this back side. I'm just kind of extruding it down, moving this out. Okay, extruding this down, moving this out with G. Okay, and you can match the shape of whatever you're trying to create, right? So that's the simple way. That's how you're kind of visualizing this as you kind of go through. Hopefully that helps a little bit break down what I was kind of going through there. There's nothing wrong with putting an image right in and modeling to it, except if you do that, you need to be good at understanding, like, hey, okay, between these two, like, you can only model to the side view, the top view, the front view. You need to have an understanding of what's going on in between those views, right? So this handle, for example, because it's curved, if I model it just to the front view and just to the side view, I'm not going to get a proper handle. That's why I'm kind of discouraging showing you to model right to an image like this, though you can, okay? You still have to interpret in between the two photos. So that's more of a next year thing. We are over time. I do apologize, but hopefully this a little bit of extra time helped you work on something for a weekly activity. If you rewatch the lecture, I guarantee you can make a drill just like that one. There wasn't anything too crazy going on. It's just a lot of steps pretty quickly, but they are repetitive steps. So once you figured it out once, it's just the same thing over and over again. So I'll end the recording there.